So in the previous class, we have discussed about the case of indicators, natural, synthetic and olfactory indicators. Okay. So these indicators are used to detect the acidic and basic medium. So when we take the case of natural indicators, litmus is an example for natural indicator, and it will show red color in acidic medium and blue color in alkaline medium. In case of phenolphthalein and methyl orange, these are examples for synthetic indicators. In case of phenolphthalein, it will show pink color in basic medium or in alkaline medium, and it have no color or it is colorless in acidic medium. In case of methyl orange, it will show red color in acidic medium and yellow color in basic or alkaline medium. Okay, then we can get into the reaction of acids and bases. Okay. So here in your textbook, you have one diagram of a reaction of zinc metal with diluted sulfuric acid, right? So you can take that diagram now. Okay, so here you can see in this experimental setup, you can see one test tube and one beaker with soap solution. Okay, so what will happen? In this beaker, we are taking zinc granules. In the first chapter also, we have done this experiment with the reaction of zinc metal with hydrochloric acid and reaction of zinc metal with sulfuric acid. Okay, here we are taking the case of reaction of zinc metal with sulfuric acid. So when we are reacting the zinc metal with sulfuric acid, what will happen? There may be evolution of some gas during the reaction, right? So we want to trap this gas and we want to analyze what type of gas is evolved during the reaction. So that's why we will place one glass tube through this test tube and we will pass this gas which is evolved during this reaction to a beaker which containing soap solution. So what will happen? Here we are taking zinc granules and we are adding diluted sulfuric acid to this, and by using a cork we are closing this test tube, and through this glass tube what will happen? This gas which is evolved during this reaction will be passed through the glass tube and will pass to the beaker which containing soap solution, and the hydrogen gas which is passed to the soap solution will coat the hydrogen gas. That means within the soap bubbles we will have this hydrogen gas, and when we show this candle, what will happen? This hydrogen gas which is inside the soap bubbles will burn with a pop sound. So that's an indication of evolution of hydrogen gas. Now we are detected that the gas which is evolved during this reaction is actually hydrogen gas. Okay, so let's get into the reaction. So here you can see that here we are discussing the case of reaction of metal with an acid. Okay, so here we are taking sulfuric acid as the acid and zinc as the metal. So when we are reacting the sulfuric acid with zinc, what will happen? Along with the evolution of hydrogen, we are getting some salts actually, and the salt will contain zinc and sulfate ions, Zn2 plus and SO4 2 minus ions. By combining Zn2 plus and SO4 2 minus, we will get what? Zinc sulfate. It is an example for salt. So when we are taking this acid and metal, on reaction of this acid with metal, what will happen? We are getting one salt and hydrogen gas. Okay, so in general when we are writing this equation, we can write it like this: acid on reaction with metal, we are getting what? Salt and hydrogen. So similar to this reaction of metal with acid, we can take the case of reaction of base with metal. Okay, so let's get into the next reaction. Okay, so actually this base is sodium hydroxide is a base, and we will get the sodium hydroxide as pellets. Okay, we want to make that sodium hydroxide into solution, so we will take the sodium hydroxide pellets in a test tube and we will add some amount of water to that pellets of sodium hydroxide. After shaking, what will happen? We will get solution of sodium hydroxide. We can call it as alkali. When we are adding when we are making solution of base, we can call it as alkali. Okay, so here in a test tube we are taking sodium hydroxide pellets and we are adding some amount of water to it, and after shaking, what will happen? Or after shaking or after stirring, we will get sodium hydroxide solution. Okay, So when we add some amount of zinc metal to the sodium hydroxide solution, what will happen? There may be evolution of hydrogen gas. Along with that, after reaction of zinc and sodium hydroxide, we will get sodium syngate. We will get what? Sodium syngate, Na2ZnO2. This is also an example for salt, similar to the in previous case. We have said that the salt formed during this reaction is zinc sulfate. So similarly, when we take the case of zinc on reaction with sodium hydroxide, we are getting sodium zingate as the salt along with the evolution of what? Hydrogen gas. So when we write this equation in a general form, we can write it like this. On reaction of metal with base, we will get what? Salt and hydrogen. Okay, so in this class we have discussed about the case of reaction of metal with acid and base. But when we compare the products of each reaction, we can say that the product is common. Only the product formed is what? Salt and hydrogen. So in general, we can write this as like this equation. Okay. That means when acid or base react with metal, we will get what? Salt and hydrogen. The salt will contain ions, cations and anions. Okay. So when an acid or base react with a metal, we will get what? Salt and hydrogen. Okay, in next class we can learn about the other reactions of acids and bases. So thank you.